Everyone stares at the chart, looking for a line that goes straight up to the right. And when they see a flat line, they panic. They assume that if the burn rate isn't exploding, the network must be dead. But here's what they don't tell you about infrastructure. A flat line in resource consumption while the actual network is expanding is usually the single biggest signal of technological maturity. You are looking at a chart that measures cost, but think you're looking at a chart that measures activity. Those are two very different things. And if you don't understand the difference between expensive RAM and cheap warehouse space, you are going to misinterpret the data every single time. Because this isn't about lack of demand. It's about a radical shift in efficiency the market hasn't priced in yet. The narrative right now is confusing a lot of people. You have this protocol, the internet computer or the world computer, that is ostensibly growing more developers, more applications, more activity. Yet, when you look at the cycle burn rate, which is effectively the revenue engine of the network, it looks flat. It's stagnant. So for the casual observer, that looks like failure. It looks like ghost town. But what you're actually seeing is something we call a utilization lag. It's a phenomenon that happens when technology gets efficient faster than can users fill up the new capacity. We need to have a serious conversation about what happened with the storage architecture on this network. We moved from a model where we were renting out expensive, high-speed boutique hotel rooms to a model where we are renting out massive industrial shipping containers. And when you make that kind of switch, the revenue per square foot drops off a cliff. Even if your capacity, say, to hold goods skyrockets, by the end of this video, you are going to understand why the burn rate is flat, why the cost of storage dropped by 200 times, and why this lag period is exactly what you expect to see, but for a shift to Web 2 scale volume. This is about understanding the plumbing, not just looking at the facade. Let's start by breaking down the old model versus what we are seeing now. And historically, storing data on this network was not cheap. We talked about roughly 4 SDR, which is about $5 per gigabyte per year. Now, in the world of decentralized networks, $5 for a gigabyte of fully replicated on-chain data is usually decent, but it's not competitive with Amazon, S3, or massive cloud providers if you're trying to host, say, a video streaming service. And the reason it costs $5 is that you weren't buying storage in, say, the traditional sense. You were buying canister memory. And think of it like this, like the RAM in your laptop. It's fast, it's expensive, and it's ready for instant computation. It's replicated across every single node in the subnet. Every time you, say, stored a picture of a cat, that picture was living in the high-performance memory of over a dozen independent data centers simultaneously. Okay, that is overkill for a JPEG, yeah. It's like, say, renting a Ferrari just to listen to the radio in the driveway. It's useless. But then the protocol introduced something called blob storage. And this arrived alongside upgrades targeted for late 2025 as we speak, specifically around Caffeine Phase 3 rollout. And this changed the game completely because the target pricing for this new tier dropped to approximately 2.5 cents per gigabyte per year. And I want you to really think about that math. That is about a 200x reduction in price. And from a financial perspective, this creates a temporary paradox. And let's say you have a developer, okay, storing 10 gigabytes of data. And the old model, that developer is burning through, say, $50 worth of cycles a year. The network shows $50 of revenue or burn. Now, let's say that developer scales up. They get successful. They now need to store 100 gigabytes, 10 times the original data. but they switched to the new blob storage model. That 100 gigabytes at 2.5 cents is $2.50. So the developer's usage has gone up 10x, but the network's burn rate from that specific client has dropped from $50 down to $2.50. And if you're just looking at the burn chart, you think, oh, the network is dying. You see a 95% reduction in revenue. But in reality, the network just became 200 times more efficient. The activity is up, the cost to the user is down. And this reminds me of something I observed during my times in traditional finance, working in the institutional space, specifically looking at the back-end infrastructure of large banking institutions. I remember, it was many years ago, a specific transition where a firm I was observed moved from on-premise legacy servers, which were incredibly, I'm telling you, incredibly expensive to maintain, cool and secure, to a modern, optimized, centralized cloud infrastructure. The quality reporting following that transition looked bizarre. The operating expenses, but for, say, IT, plummeted. And if you're an outsider looking only at, say, the spending column, you might have thought, oh, okay, they must have fired their engineering team or they stopped developing new products, The spending line flatlined completely. But internally, the capabilities had exploded. They could now process transactions faster and store more client data than ever before. The burn of cash went down, of course, because the technology improved. It took the market about 4 quarters to realize this drop in spending wasn't a contraction, it was a margin expansion. It was efficiency. The banks that made that switch early were able to weather the next financial test stress much better than the ones clinging to the expensive, heavy legacy systems. And we are seeing a very similar dynamic here right now, because the ICP protocol has optimized its cost structure and the burn rate chart is currently lying to you about the health of the ecosystem. And now let's talk about the concept of the empty warehouse, because this concept connects to the recent Stellarator and caffeine upgrades. These updates unlock the ability for single canisters, the smart contracts that run everything, to hold over 100 gigabytes of stable memory with a trajectory toward 1 terabyte. Imagine a developer is, say, a shopkeeper. Previously, the network gave them a small closet to store their goods. The closet was always full and they had to pay a premium for it. Now, but the ICP protocol has basically gifted them a massive industrial warehouse. The capacity limit has been completely removed. But here is the catch. Increasing the limit costs the protocol nothing, and it costs the developer nothing until they use it. Just because you have, say, a 1 terabyte warehouse doesn't mean you have 1 terabyte of stuff to put in it yet. And this creates a utilization lag. The protocol has built a massive skyscraper. It is gleaming, it has high-speed elevators, and the rent is cheap. But right now, only the lobby and the first floors are occupied. The burn rate reflects utilization, not the capacity. And if you look at the total available memory on the network, it's shooting for the moon. And if you look at the used memory, it's growing, but at a normal pace. The burn rate won't start to tick up aggressively until we see what I call Web 2 scale ingestion. We need applications that aren't just storing the lines of code, or token balances. We need applications storing video, massive AI training. We're talking inference, training, datasets, and comprehensive user logs. We need to fill the warehouse until that warehouse is full of petabytes of data. The burn rate is going to look relatively flat until then. And that is actually healthy, because if the burn rate was skyrocketing right now while usage was only moderate, it would mean the network is too expensive to ever achieve mass adoption. You want the price to be low now so that the volume can arrive later in the mass adoption phase. And I want to touch on the reverse gas model and all of this, because this is a critical piece of the puzzle that is very different from say Ethereum or Bitcoin. Because in those networks, if the network gets busy, the fees spike, the burn goes up because of congestion. High fees are seen as high demand, but they are actually a failure of scaling. On the internet computer, the model is designed for stability. Costs are fixed in SDR, which is a basket of stable currencies. If the network becomes, say, 20% more efficient, say thanks to upgrades like Tokenomics for latency or Beryllium, the cost to perform an operation effectively drops. The definitive foundation and the engineers contributing to the network are constantly optimizing the code. So when they release an upgrade, say, that makes data processing, say, faster, the burn rate drops. Think about that success in this context looks like a drop in revenue in the short term, yes? I recall a situation, involving logistics company analysis I was privy to years back when I was working in finance. They implemented a new routing software that saved them 15% on fuel. For the first quarter, their fuel spending, their burn dropped significantly. And if you were a supplier selling them fuel, you'd be worried. You'd think, their business was shrinking, but in reality, their business was the same. They just stopped wasting money on inefficient routes. And the reverse gas model ensures that developers have predictable costs. And this is what brings institutional money. Big enterprises and serious developers cannot build on a platform where their rent might double tomorrow overnight in the next hour because a meme coin became popular. They need flat, predictable, low costs. And the current flat burn rate is the proof that this network is adhering to that promise of stability. And we also have to consider, what is actually driving the burn right now? It isn't the storage, it's compute. And there is a distinction between, say, active and passive burn. A canister, just say, holding, say, 10 gigabytes of data is sitting there, say, relatively passively. It burns a slow, steady trickle of cycles to pay for its rent. It's, say, like storing, like a storage unit. You pay the monthly fee and that's it. And on the other hand, a canister that is running, say, a high frequency trading bot or an AI inference agent, or say a complex DeFi protocol, is burning cycles every single second of the day. It is processing instructions, making calculations, sending messages constantly. And that is where the fire is. And currently, the ratio of compute to storage is heavily skewed. We haven't reached the era of big data on-chain yet. We are in the era of complex compute on-chain. And until we have exabytes of data stored, the storage costs are going to be a rounding error, say, compared to the compute costs. And this brings us to the long storage factor, because this is a technical detail that most people just gloss over. But it's huge for the burn rate metrics, because with the Beryllium upgrade and the patches that followed in this year, developers were given better tools to handle their logs, because in the past, developers had to be lazy. They would just clog up that expensive RAM with system logs, error reports, and user history. It was inefficient, and it burned a lot of cycles. It was like keeping your trash, say, in your living room because you didn't have a trash bin. You know what I mean? You just, and now they could offload these logs to, say, cheaper storage tiers or a peripheral storage, but they can flush the system, and it's just, this immediately reduces the burn rate for existing applications. It makes the chart look worse. I'll tell you why. Because less money is being wasted on storing junk. Structurally, you're going to think of it like this. It means that applications are running leaner and faster. So let's create a clearer picture in all this. Because what is happening using, say, real world analogy to explain it. Imagine a city that runs on a toll road system for years. The roads were narrow, full of potholes, and the toll was $50 per car. The city didn't have much, say, traffic because only the richest people could afford to drive. The revenue for the city was steady, but low volume. Then the city decides to, say, upgrade. They built a massive 12-lane superhighway that smoothed out the pavement. And most importantly, they dropped the toll from $50 to 0.25 cents overnight. The city's revenue from tolls crashes. It drops by 99%. The local news looks at the revenue chart and says, ooh, the highway project is a disaster. Revenue is down massively. But they're missing the point here. The highway isn't empty. Cars are starting to line up. Trucking companies, what are they doing? Cancelling their contracts with railway and planning to use the highway. Logistic firms and building warehouses at the exits. The volume is coming, but it takes time for the trucking fleets to buy new trucks and plan the new routes. And that is where we are right now as we speak. The internet computer has built the 12-lane superhighway and lowered the toll to a quarter. The burn rate has dropped because the old expensive traffic is paying less. And the new massive traffic, the Web 2 scale fleet, is just starting to turn their engines on. And I want to share another observation of this from my background in finances, specifically regarding infrastructure investment cycles, or what we often call the J curve. Okay, I'll keep it simple. There's always a painful period in any major infrastructure project where the capital expenditure, the spending to say build the thing, is finished, but the operational revenue hasn't started yet. So we used to see this with, say, fiber optic cables. So in the late 90s, companies laid, say, dark fiber across the entire ocean, miles and miles of it for years. That fiber sat dark. It wasn't used, no. The price of bandwidth crashed because there was so much supply that everyone said it was a bubble. They said nobody would ever need that much bandwidth. Why do you need fiber speeds to check, say, email? They asked. They were looking at the utilization lag. They couldn't foresee streaming video, cloud computing, mobile data, AI. Once these applications arrived, they needed the bandwidth. That dark fiber lit up, and it became the most valuable asset on the planet. And the storage capacity in ICP is currently dark fiber. It's cheap, it's abundant, and it's waiting for the application that needs to, say, store a 4K video 100% on chain without censorship. It's waiting for the centralized social media platform that hosts millions and billions of user profiles. And when those applications arrive, they won't be paying $5 a gigabyte. They couldn't afford to. They'll be paying 0.025. And because they can afford it, they will bring in petabytes of data. And that is when the burn rate goes vertical. Not because the price is high, but because the volume becomes astronomical. So if you're analyzing this protocol, you have to ask yourself, do I want to invest in a network that artificially keeps prices high to make a chart look good, which is pretty much everything in crypto? Or do I want to look at a network that is ruthlessly lowering costs to capture the entire market of the future? The burn rate is flat because the protocol is acting like a competitive business. It is slashing prices to gain market share. It is optimizing its supply chain. And let's look at the price cliff again. $5 versus 0.025. This isn't just a discount, it's a paradigm shift. At $5, you're a niche blockchain for high value financial data. At 0.025, you're a legitimate competitor to AWS, Google Cloud, and Azure, but with the added benefit of full 100% decentralization and smart contract integration. The market for cloud storage is a multi-trillion dollar industry, and the market for blockchain storage is tiny. By moving the price to 0.025, the internet computer has decided to stop competing in the tiny kiddie pool of blockchain and start competing in the ocean of cloud. But you don't drain the ocean overnight. We also need to consider the developer psychology here. And if I'm a developer and I know that storage is expensive, all right, optimize minimal code, of course. I didn't save anything. I don't have to. I'm scared to scale. So when you tell me, okay, storage is effectively free or close to it, my behavior completely changes. I start building features I couldn't build before. I start hosting full websites on chain. I start uploading high resolution assets. But there is a lag between telling me the price is low and me finishing the code that utilizes that cheap storage. That is the utilization lag. It is the time between the price drop and the innovation spark. The upgrades, Stellarator, Caffeine, Beryllium, these are not just cool names. They are structural changes to the economics of the network. And let's be real about the burn rate in all this. As a metric in the crypto space, people are obsessed with deflation. They want to see tokens burning so that the supply goes down and the price goes up. I get it. It's very simple, somewhat primitive way to value a network. But the internet computer isn't just a token. It's a computing platform. If Amazon Web Services raise their prices, say 1,000% next year, their revenue might jump for 1 quarter, but then everyone will leave. Their burn would be high, but their business would be dying. You want a platform that drives value through volume. The burn rate will rise, but it will rise because of millions and billions of transactions and petabytes of storage, not because of just say high fees. The stability of the reverse gas model is a silent killer of the competition. While other chains in the crypto space are having crisis because of gas fee spikes during NFT mint, ICP developers are sleeping soundly. Their costs are fixed. This stability is boring, yeah, I get it. It doesn't make for exciting tweets, but it does definitely make for enduring businesses. I remember talking to a portfolio manager many years ago in my institutional days about utility companies. He said, I remember verbatim, I like businesses that nobody talks about until the lights go out. He meant that boring, reliable, cost-effective infrastructure is where the real long-term value lies. It's not flashy, it's not volatile, it just works. And it's cheap. And the ICP storage decoupling is exactly that in a nutshell. It is the network becoming a boring, reliable utility. And that is the highest compliment you can pay to infrastructure. The log storage shift is another example of this maturity by the Definitive Foundation. By allowing developers to separate trash data from treasury data, the network is acknowledging that not all data is created equal. This segmentation is standard in Web 2. You have hot storage for things you need instantly, okay? And cold storage for archives. So bringing this logic to a blockchain is revolutionary, but it deflates the burn rate in the short term because you are forcing people to pay premium prices for cold data. So where does this leave us? We are standing in front of a massive empty warehouse. The rent's cheap. The lights are on. The roads leading to it are paved. The chart says nobody is here yet, but if you listen closely, you can hear the trucks are coming. The burn rate is flat because the cost of storage has dropped faster than the volume of data has grown. And that is a summary. The capacity limit has gone from a few gigabytes to terabytes per canister. The primary burn driver has shifted completely from expensive storage to pure compute and AI inference. And the next phase isn't about the price going back up. No. The price will stay low. The next phase is all about the volume catching up to the capacity. We are waiting for the Web 2 scale applications. When you see a video hosting platform running entirely on chain, utilizing that 0.025 blob storage, you will see the burn rate move. When you see an AI model storing its entire training history on chain for verification, you will see the burn rate move. But you have to have patience to sit through the construction phase. You have to understand that when the cost of business drops, business eventually booms, but it doesn't happen the same afternoon. It doesn't happen in a few days. So ultimately, understand this decoupling can completely change how you approach analyzing this network. And the key lesson here is simple but powerful. Efficiency looks like stagnation if only measure their expense, not the capability. The burn rate isn't broken. No. It's recalibrating for a new era of mass scale. But patience is required. And this perspective might just shift the way you see the world of decentralized infrastructure. And think of this the next time you encounter a flat chart, because it could make all the difference between spotting a dying project and spotting a sleeping giant that just needs patience. And that's the story behind the disconnect between the capacity and cost on the internet computer. And with that wraps up today's journey into the mechanics of digital storage economics. Everything together, what we've done today, when we see it from this angle, is not as a loss of revenue, but as a preparation for growth. And remember, stay curious and let your journey continue, because everything we've explored today could change the way you see the underlying value of these networks forever. Remember, the choices you make today in how you interpret data shape tomorrow's story. And hopefully, if this video cut through the noise and actually gave you clarity, not hype, not hopium, then do 3 things right now that are important. Hit like, so this reaches people who are tired of being misled. Subscribe, because this channel is all about understanding where technology, money, and power are actually going before the headlines catch up. And comment below with what clicked for you, or what, say, you want broken down next. I read every single comment, if it's valuable, of course. And if you want signal instead of noise perspective, instead of panic and clarity before consensus, subscribe right now. And if this video inspired you, give it a like and share it with others. It's deeply appreciated. And drop a comment below. I want to hear your thoughts also and experiences in this regard. And don't forget to subscribe and turn on notifications so you never miss the next adventure. And importantly, all this, stay decentralized, and I will see you on the internet computer. Until next time.